Sir, you can start now, sir.
Guru, thank you. So welcome participants for this online discussion on the topic, advances in power transmission. If any queries, you can start typing, or you can also ask the questions. We will be able to help you out. Hello, good afternoon, Vasant, Mohammed, and Kaushik. If there are any queries, you can raise or you can also type. Hello.
Yes, sir, we can hear you.
Yeah, yeah. Mr. Mohammed, there is a question from you.
Yes, sir.
Yeah, you have asked about the long transmission line. You have doubt about the HVDC. See, in the country, you must be knowing that HVDC is used for long transmission because there is some limitation over 400 kilometers, and long distance transmission AC will be not economical, and also technically the resources which are available depending upon that HVDC is planned, and huge amount of power also can be transmitted in comparison with the AC. So your question is about how long transmission voltage is stepped down. See, there are two things like power transfer by HVDC. It will be in terms of bulk transfer. It could be in terms of megawatts. Typically for 800 kV HVDC, it will be around 6,000 to somewhere in that range where the power is being transmitted. And once the power is being transmitted, nearest receiving station, again there will be converter stations or an inverter stations, what we call. So the voltage will be again converted back to the AC, and from that AC, suitably either it could be at that voltage level, it could be at 400, or it could be at 220, or it could be at 110/66 AC, and down the line again for distribution or industries, it is done in that way. So there is no straight away step down of the HVDC at different levels. It is stepping down at the converter inverter station, and it is converted back to AC, and from that AC is distributed. That is how it happens.
So thank you, sir.
Right. We have Vasant, Jayesh, Shashi, and Asha. Asha Sende. Any questions, please?
Excuse me, sir.
Yeah, please. Go ahead.
Sir, as we see many transmission towers around us, and we see they are very long transmission lines. And sir, how can we find out which line is coming from where? Sir, is there a mark on towers?
I'm not able to get the question. Can you please repeat the question, please, once again?
Yes, sir. Yes, sir. Sir, as we see many of our transmission tower around us, they are transmitting from long distances. Sir, how can we identify which line is going or incoming? Sir, is there a mark on towers?
Okay. See, typically the transmission lines, when you see whether it is a 400 kV, 800 or 220, there will be known to the people at the receiving end and the generating station. Like example, if you see from there is a line from Kolar to Bangalore, which is HVDC line. So all of us know the generating is somewhere near the Kolar and it is being transmitted to Bangalore. So that is where near the tower, if you go, it is very difficult to say. I don't know whether because of the tower, the height, tower over a period of time, if there is marking or something, I don't know really about that aspect. But only you will be able to find out what is the voltage level which is being transmitted and what is the voltage level which the tower, by looking into the insulators and looking into the number of insulators in a string. Suddenly, if you be in the field from which line side which it is going, yeah, I don't know whether there is any marking for the like a arrow mark which comes from this side to that. I really don't know. I have to talk to some people who are in the distribution. I really don't know. I can only tell what is the voltage level.
Yes, sir. Yes, sir. Thank you.
So from YouTube Live, Smith Joshi has asked, what is the definition of current? I am ECE student.
What is the definition of current? Current is the rate of flow of electrons. See here, electric current, if I say anything, if you just say it is a current, current can be a water. It is the rate of flow basically. So when you are talking about electric current, it is the rate of flow of electrons in a particular conductor. So that is the simplest definition which I can give. Rate of flow of charges or whatever you call rate of flow of electrons. EC also there is a flow of current. No? You cannot say escape that you don't know current. He's from institute, I think. Because you see this institute now.
If we can proceed to the panel questions, there is a question from Vidyasagar. Can you elaborate on the essential differences in the components of DC substation and AC substation?
Okay. What is that question?
Essential differences on the components in DC substation and AC substation.
The DC substation and AC substation, as I was mentioning, it will be basically the DC transmission is there. From the DC transmission, you have a converter or inverter stations, what we call. There again, you have all the filters connected with the capacitor banks and many of these things. Circuit breakers, again, you have specifically protecting devices, isolators, switch yard similar to your AC substations. You have all the protective gadgets like the lightning arresters, then group operating switches, then you have CTs, PTs, everything remains same. It is for the DC level. Once again, the you have a transformer converted to AC, and mainly converter or inverter station will be there from the DC side. And other side, once the inversion takes place, then again AC substation will be there. So both AC and DC will be adjacent to each other. When the DC line comes, it has to be changed to the AC. This is how it happens. What is the next?
Ranjit is asking with how many assignment questions are required to pass the exam.
You should answer. I don't know. What is it? Like, how many we have?
40% they need to clear the marks.
Ranjit, I think 40% will be that. I think last exam will be for 50%. No? 50-50, no? Actually 50-50. So assignments is 50 and final exam is 50.
Yes. Total 40
So, total you have to get 40 for passing. That is how it happens. So assignment 50% and final exam 50%. If you take, there should not be a difficulty in passing the exam.
Sir, as you said, converter and inverter substations are there for DC to AC conversion. Sir, how was the rating is given to those inverters? Sir, how many is range?
No, rating means again I was telling that there are DC transmission lines depending upon the voltage level. So if it is plus minus 200 kV, plus minus 500 kV lines are there in the country, plus minus 800 kV lines are there in the country. So depending upon the voltage levels only, this suitably this your equipment also will be designed. That is where if it is an 800 kV or a 400 kV substation, like how you have AC, similar to that, the same rating capability of that equivalent voltage level should be there in the substation. This is how it happens. You cannot have higher or lower rating. For 800 kV substation, you have 800 kV switchgear related to the either it is an AC or DC.
Okay, sir.
Yeah, yes, please. Here it is heavily raining. Slightly be louder so that we can hear properly. Bangalore, we are flooded with rains. Right now it is heavily raining. Slightly questions, you can just increase the volume so that I'll be able to hear properly. Thank you. Any message? Or you can type the question. If you have difficulty in conveying, we will try to answer it. Not able to get the audio. Somebody, Vidyasagar, something. Regarding isolation of defective surge arrestor in a cascade system of several elements in a surge arrestor, how can we detect and isolate of a single element in the stack is not functioning properly, that it is open and does not divert the surge? Sir, where and which is the biggest transmission line in India? Okay, there are two questions. This is, I think, from Vidyasagar. He has a question regarding the surge arresters. He asked regarding isolation of defective surge arrestor in a cascade of several elements in a surge arrestor. How can we detect and isolate a single element? Vidyasagar, yes, you are right. In a surge arrestor, depending upon the voltage level, the number of surge arrestor blocks, what we call, or a zinc oxide or a silicon carbide. Earlier, silicon carbide arrestors used to be put in the stack, and top and bottom will be the pressure valves and also the contact point pressure relief valve, what we call. So yes, number of surge arrestor blocks will be there depending upon the voltage level. In case there is a failure, to one of the discs, it is very difficult to identify in the field conditions, because all of you know that this surge arrestor is enclosed in a housing. Either it is a ceramic or a recent, it could be a polymer housing. So difficult to get the exact location of the faulted surge arrestor blocks. So generally, if the arrestor is removed in the field, or it will be detached from the existing supply, and they have a suitable mechanism to find out if it is not properly functioning, then they try to remove and open up. Then without opening, it will not possible for us to exactly identify which block is bad or which number of blocks are bad. So this is difficult to say unless you open and see the thing. So definitely one or two blocks goes bad, surge cannot be diverted and it will not be functioning. And also nowadays, when you go to the substation, you can see the leakage current of the entire surge arrestor, which the measuring device is kept at the bottom of the surge arrestor, which gives an idea whether the surge arrestor is healthy or not. So based on the leakage current, normally it is in terms of few microamps or maybe a couple of milliamps. So you can say the surge arrestor is in functionality or not. If there is a problem, there will not be the indication, and definitely the maintenance guys have to take care of this and immediately put a replacement and then look into the investigation part. This is how it is done. So exact identifying in the number of blocks physically, because it is enclosed in the housing, very difficult to say where exactly unless it is opened up. Vicky has some question. He says, sir, where and which is the biggest transmission line in India right now? For AC, we have 800 kV AC lines are several in the country. I can tell you a few of them. One is from Tamil Nadu, that Pugalur to Madhya Pradesh is 800 kV. One more is from Arunachal Pradesh to Agra. That is again 800 kV, more than approximately 2000 kilometers line. So apart from that, there are several other 765 or 800 kV AC lines in the country. You can just for more details, either the Central Electricity Authority or a Power Grid Corporation of India, you get number of AC lines. You get the entire map of the power map of the country, where 400 kV, 800 kV, even HVDC. I am also talking about HVDC and HV AC lines, which are there. You can have the information on the website of Central Electricity Authority or a Power Grid Corporation of India. Presently, we have in the country both AC and DC at 800 kV level operating. Several lines are there. Ankit, I think Ankit has a few details about the kilonewton capacity of insulators with respect to the voltage level and the tension level of the materials used. Ankit, this is very important, for glass and ceramic insulators, like polymer is being widely used nowadays. So this is a very good question. So Kilonewton is the mechanical strength of the insulators which are used for the transmission system. So depending upon the area, depending upon the voltage level, this is chosen. Say 70 kilonewton. 70 kilonewton is typically used for a very low voltage level at 33 or 66 kV level. So the insulators, either ceramic or a glass or a polymer, are typically rated for 70 kilonewton. The next is the 90 kilonewton, then you have 120, you have 160, you have 210, you have 320, you have 420, you have 520. These are the different kilonewtons depending upon the voltage level. The higher number for 800 kV, you have HVDC, which are 420 kilonewton. And these are huge insulator, which each insulator, say 70 kilonewton, typically has a weight of somewhere around 6 to 7 kgs. Whereas if you go to 420 or 520 kilonewton insulators, they will be around 16 to 18 kilos each insulator. So these are generally used for very high voltages near the river crossings, huge towers, windy conditions. So the kilonewton rating is chosen depending upon the lines which are passing in that particular area, windy area, normal area, voltage level. So all these factors matter. I cannot simply say 70. There are where say 90 kilonewtons are being used for lower voltages also, where areas are prone for wind, like it could be like Rajasthan or some of the places.
So Mahindran Ramaswamy from YouTube Live is asking, what is the definition of transmission?
Transmission, particularly I refer to the transmission of power in our case. So transmitting power from the generating stations to the load centers. Again, transmission of the power, it could be because of renewables, because of solar, because of wind, because of hydro, because of nuclear. So in my case, I refer the transmission for power through the transmission lines, overhead or underground cables.
Excuse me, sir.
Yeah, please.
Sir, in transmission towers, we see some insulator strings are hanged vertically and some insulator strings are horizontally attached to the wire. Sir, why is that?
Yes, you are right. Good observations. In any tower, it is not only two, you have 4 to 5 configurations. Yeah, I will tell you, there are 4 to 5 configurations. There is suspension type, we call it a pilot string. You call it, sometimes there will be 2 strings which are in horizontal, we call it as a twin insulator, twin conductors with 2 conductors. Sometimes with 4, we call it as a quadruple insulator string. And when you go to the higher voltage, you have 6, 8 or 12 numbers of conductors. So these insulator strings of different configurations, apart from tension, apart from suspension, you also have what is known as a V configuration, similar to V type, or a double V, single V, double V, single I, double I, double horizontal, that is a tension, or quadruple tension. So several of these combinations do exist. Maybe you have checked 1 or 2 cases, similar cases, wherever there are crossings or wherever there is a junction point, you have all these combinations. So you do require these combinations whenever the lines are getting perpendicularly which are from one end to other end, transmission is to be happening. If it is a straight one tower to other tower, typically you see the horizontal configuration or a tension arrangements, what we call. So when there is a 90 degrees or a perpendicular way of diverting the transmission lines, then you have these combinations of V type and also the suspension. So these 4 to 6 different types are also seen in the transmission system at various voltage levels. It is mainly to ensure the conductors do not come near the tower. So minimum clearances have to be adopted. So all the conditions like the wind, the swing of the conductors have to be taken into consideration. So wherever the I suspension is there, it is may not be needed, but wherever there is a requirement, the people go in for clearances. So we have to go in for V type or higher voltages, 4 conductors or 6 conductors, 8 or 12 conductors, depending upon the power which is being supplied.
Good afternoon, sir. I am Dr. Asha from Pune. Sir, now for HVAC, which area is, if we want to do the research in this area, So based on this knowledge, which area will we have to concentrate, focus, sir?
Madam, in EHV, UHV, like whenever the voltage levels are going up, there are a lot of challenges for the utility engineers and also the power companies. Once the voltage levels goes up 765 or 800 kV, there are also challenges, equal challenges, like not only the insulation aspect, it could be because of designing the higher rating switch gear. It could be a transformer, it could be surge arresters, it could be many of the things. Apart from that, the insulation levels for the transmission levels, the area like the problems of designing the newer conductors, it could be radio interferences issues, it could be the conductor managements at that level, the tower issues which are coming up, huge uh, infrastructure, bringing down the tower size, bringing down the many of these things are also mechanical and also partly electrical related, and there are issues pertaining to the clearances. There are issues pertaining to so several are there, madam. It is not one or two topics which it is there, and even in substation engineering, there again when you are having at 800 kV level, the bringing down the voltage to the required levels, the again SCADA issues or where you are trying to see how the voltage is brought down. Distribution also is again a part and parcel of the transmission system. So several things are there. Research areas, people are again focusing on various things. It could be one of the protection part, which is very important. So a lot of activity pertaining to the HVAC or a DC protection systems. It could be surge arresters. It could be the issues related to the transmission flashover issues of the insulators, designing of corona control rings, designing of proper insulation. So several factors are there where people can work with the help of utility. I always suggest at this level doing something at independently may not be right. So you should try to have some linkage with the utilities or the power companies. Then they also will be facing some issues pertaining to this. So such topics, if you are able to address, then it will be very good for the companies and also for the people who are for us who are trying to do something on that. So a lot of, even in a material aspect, it is simply we are following earlier ceramic, glass and polymer. Now a lot of people are also still looking on some failure analysis, like composite insulators do fail because of the brittle fracture of the fiberglass rod, or the problem with the silicon rubber over a period of time. Hydrophobicity is one of the issue. Then degradation because of the organic nature of the insulators, it gets degraded over a period of time. So there are several issues needs to be looked into. So that is one of the reasons where I say either industries or utilities, or if you are closely in discussions with them, that will also help you to choose an appropriate topic for research work and also contribute to some utilities which will be useful. Not doing something simply some simulation work which is may not be of very much relevant. So choosing practical issues, that is how we should try to involve. So that is my take.
Okay, sir. Thank you, sir.
Yeah, thank you. Any other question, Nathan?
So could you please tell me what is the exam type of, is there a written test or anything?
There is a question from Mohammed again. See, Mohammed is preparing for IAS and is asking small questions here. Mohammed, you are here?
Yes, sir.
He is asking, अरे यार अब तो IAS prepare कर रहा है, ऐसे तो कुछ questions तो ये तो simple questions है यार. Whatever you are asked is we don't have any like descriptive type. It will be multiple choice as you told. There will be some 4 questions. Sorry, 1 question, 4 answers. And only thing you have to be a bit careful sometimes. Out of the 4 answers, 2 may be right, 3 may be right, 1 may be right. I don't know that part. So you have to be a bit careful. So sometimes you feel 2 answers be correct, correct, rahega bhi. So marks are there for 2 or 3. So it will be multiple choice for a question and 4 answers. And sometimes it could be like true or false also. Some few questions could be also of that nature.
Sir, actually I'm writing first time, so that's why I asked it.
Okay, okay. No problems. So it is a multiple choice only. I think our people in NPTEL office would have mentioned, I thought, I don't know, because once we give the question papers to them, they will take care of all those things. It will be multiple choice only. Some 50 questions will be there, or that equivalent of that numbers, either 50 marks or whatever it is. You have 4 choice or 2 choice, either true or false, or but only thing, as I again mentioned, it need not be only one single answer, right? There may be 2 or 3 also sometimes. That you should keep it in mind.
Yes, sir. Yes, sir. Thank you.
Right.
Sir, Vidyasagar has asked.
What is that even? Regarding maximum exposure time of a human being under various electric field. It is mentioned that the maximum exposure time for a voltage gradient of 25 kV per meter is 6 minutes. For an average person of height 2 meters, under this condition, the voltage between his head and feet would be of order of 50 kV. Would it be possible to survive such voltages? 25 kV per meter in 6 minutes. I think there is bit confusion. Vidyasagar, whatever the values mentioned, it will be like when people are working near the substation or high voltage yard or near the transmission system, the government has fixed the, yeah, it is 5 kV per centimeter, or the values are specified. So these you will not be there. Like example, in the substation, people who are working, it will not be exposed continuously. They will be there. They have to do some maintenance work. They have to be there. So in such cases, it is preferred not to be there continuously. And during that period of time, normally switchyard is isolated. People work there. During the energization for minimum clearances will be maintained. It is not that people will be affected with the voltage level. So that is taken care in switchyards, substations, and also in the transmission systems. Yes, there is some recommendations which are at the international level, where people should not be exposed both for electrical and magnetic fields. This could cause some issues related to the human. Any other questions? I think Vicky has some question. In case of insulator life durability, which material has maximum capacity to withstand in heavy 4 voltage surges? And nowadays, which material is in insulations are used? So Vicky, as I was mentioning, from last 100 years or so, initially when the transmission lines were started for lower level 11 kV and above, so ceramic or porcelain, what we call, people started using in many of the countries, including India. So I would like to mention insulators are much older than the power transmission. So these insulators were used for telegraphic earlier days, much before the power transmission came into existence. So what they did initially, they used the ceramic or a porcelain pin and cap insulators, which are used for telegraph. Later on, when the voltage level were higher, there were flashers. That is why how the insulation insulators started coming into the picture. And 2 of the important people who were responsible for this were from General Electric and Niagara Falls. That is where the first ceramic insulator were designed. Then these were used in different creepages, different designs came up. And ceramic, porcelain were being widely used across the globe. Europe, because of the availability of glass, they have been using the glass to a larger extent. Their ceramic or porcelain are being used to a certain extent, but glass is widely used among the Europe. Now, for last 2 decades or so, roughly around 2 to 3 decades, the polymer or a silicon rubber or a composite, what we call, all are same, what I am mentioning. Polymeric silicon rubber or a composite insulators have come into existence. Again, these have a fiberglass rod in the center and a silicon rubber petticoats embedded on the fiberglass rod. So these are being widely used nowadays for all voltage levels. It could be for railway traction at 25 kV level to 800 kV level. So they are trying to use these composite insulators, and slowly the ceramic or glass are being replaced to a certain extent. It's not that completely ceramic is out. Yes, they have reduced drastically. There are some advantages of using this polymer or silicon rubber because of lightweight, because of better hydrophobicity, and also not much of aging things which we knew. So they people started using, but there are also issues with this material. So right now, a lot of fillers are also being added to this and trying to make the materials better. So composite materials are coming into the use, and a lot of transmission systems, composite or silicon rubber or polymer are being used. Do we have any questions from, I see Nikita is here, Prasun, Satishan, Saurabh, and we have Shishi also here. Any questions? I think Satishan immediately writes a question. I am standing 5 meters away from the 110 kV line. What will be the electric field, MTR, and is it dangerous to my body? Satish, 5 meters away from 110 kV. So 110 kV transmission line is typically at a 10 meters. Sometimes it depends on 8 meters. What is the minimum height of the transmission line? I don't know whether you are referring to the transformer or a transmission line. So even in the switch yard, suppose if you are near the transmission line or a transmission transformer, so 100 kV, you know, near the transformer, they would have put a fencing, they would have minimum measured all the electric field, magnetic fields which are near that. So the people who are working at the substation, before the substation is being energized, there are quality checks for that. A lot of electrical inspectorates, particularly people who are involved in giving the permission to the substation, they do check all this electric field, magnetic field, the clearances, everything. So if they are on par with the national and international standards, then only they allow the substation to function and the people can work there. So most of the cases, it is definitely not a problem working near the areas. There are fields measured at regular intervals. A log is being maintained at the substation or at the substations where the people are working. So I don't think there is a very serious issue. And if that is where many of the time the transmission lines are constructed at a very higher height, even during the foul weather or the rain conditions or the moist condition, the electric field should not be an issue with the people or animals passing nearby or the vehicular traffic. So all these things are generally taken care, and I don't think need to worry unless there is where a right of way is encroached upon and people construct a house under the transmission lines. There could be an issue. Other than that, typically nothing or serious issue. It would have been taken into consideration while the energization of the substation. Yeah, somebody, I think Satish.
Sir.
Yeah. Satish, it's not clear here. At least if you can type your question. I'm not able to hear you clearly.
Sir,
Sorry, Satish, I'm not able to get your question. You can write your question.
there is a network issue.
Mohammed has a question. Why can't we use underground cables for power?
Why can't you use underground cables for power? Yes, Mohammed, it is possible. The only problem is for long distance, there are a lot of other things. It is again the charging currents is one thing. Long distance underground cabling, we do have from like example, I can give a line from Sri Lanka to India, which is being very recently energized. It is in the sea, where the cable is being used in the sea. So there are cases for long distances. It is very difficult. Not only the economics also is a costly thing. Second is the charging currents play a role there. So here we have much cheaper and more economical to go for overhead transmission. That is one of the main aspects. It is possible to use underground. It is not that many of the cities you see underground cablings are being used for transmission, distribution basically. For long distance transmission, yes, you do have some technical as well as the economic issues. That is the reason. Is there any other things there? No.
From YouTube Live, Mahendran has asked, sir, how many types transmission line and definition?
How many?
Types of transmission lines and their definitions.
Mahendran question, how many types of transmission lines? Types of voltage level only I can tell. It could be 11 kV or 33 or 66 or 132, 220, 400, 765. Presently in the country, they are also going in for 1200 kV AC. Experimental line is in progress in Bina in Madhya Pradesh. So 1200 kV AC could come up very soon. Types in the, I didn't understand that thing properly. I don't know. He's asking for different voltage levels or types in the sense is voltage levels itself is types. I don't know. YouTube question.
One more YouTube question is Yogesh Kumar is asking, please brings online exam questions.
Okay, Yogesh wants question and answers for the final exam. So he wants me to broadcast all the questions. It is a multiple choice questions. Earlier also we had been discussing with Mohammed. So it will be a question with followed by 4 answers. So answers may be 1 or 2 or 3 correct answers. So you have to write all the things. So it is a simple question with 4 answers, which will be there. You will be able to write down, not difficulty. I don't see any difficulty in that. I also don't remember the questions. Otherwise, I could have given. Vidya Sagar has a question regarding corona discharge at the surface of the transmission line. The voltage gradient on a conductor would be very, very low and not capable of producing a corona discharge. Are you referring to corona discharge between the conductor of different phases? I am unable to appreciate this. First of all, the corona discharges on the surface of a transmission line, yes. So it is not that the conductor is very, very clean. Sometimes even a small abrasion, small cuts, even a small damage will cause the discharges on the surface of the corona. So it is very difficult to design a conductor with completely corona-free conductor. Not at all possible. So, and not at all possible to install it in the field. Stringing also is equally, many of the time you people may not know. The conductors are there on the big bobbins, huge bobbins, and they drag on the field to connect from one tower to other tower. So even the rating of the conductor, it could be higher, but when they are dragged on the field, they are on the road or on the field, the conductors too partially gets damaged. And on the surface, definitely there will be a localized discharges which are happening, which normally happens at a very a higher voltage levels. So which sometimes you will not be able to see it. So in the night, carefully, when you see very high voltage lines, you see the small surface glow or the audio noise or the visible corona on the transmission lines. Definitely you will be able to see when you go above 400 kV transmission lines. So it is not that the conductor will not be able to give the discharges. Definitely there will be surface discharges on the transmission line conductors, and on the phase conductors will be there. Yes, depending upon the load conditions, the surface discharges will also be defined. It is not that it is completely corona free or corona discharge free conductors. It is very difficult. That is what we were referring. That is the reason where these conductors are done for RIV, corona. These tests are being carried out in the lab before they are installed in the field. So they want to see that the noise generated by these conductors when it is energized should not cause any issues to the radio circuits or television circuits or to the communication, like the police personnel use at a certain frequency. So these noise generated by the transmission line conductors could cause an interference with this electronic circuits or radios. That is the reason these discharges, the noise levels should be kept at a minimal and the interference should not be into this communication circuits, or the noise which is generated should not cause any I think Vicky has a question assignment which we are giving right now in course is also contains 4 out of 4 options too. Could be one of the case. I do not rule out. There could be. In 1 or 2 cases, there could be. Yes. What is the difference between the impedance of surge impedance? Line impedance. See, when the difference, typically what happens, the surge impedance of a transmission line, when we say, usually it is the surge is what? Lightning or a switching activity which is happening. So in such cases, what is the impedance offered with the transmission line is the general consideration for all the design parameters. So for this, typically we, as a power system, when you look into various books or the literature, people start taking somewhere around 250 ohms to 400 ohms. Typically, for 250 to 300, 350 is the surge impedance of the transmission system. For the design of various equipments, when we look into the cases where there could be a lightning strike, there could be a switching, there could be a over voltages. So for that, it is very, very essential. This is typically assumed somewhere around 250 to 350. In some of the books, you also see some 400 ohms. It depends. Like, as I told, if it is a single tension or a double tension or a quadruple tension, this surge impedance values chosen for the simulation or a practical consideration will have a very minimal effect. So somewhere around 250 to 400. That is how this is very important for the design of various equipments for the protection. Amresh, can it be possible to use moose conductor for 220 kV transmission line? What is the current carrying capacity for moose conductor and zebra conductor? Amrish, yes, there are various conductors. It is not that you should not use moose. Moose is typically used for 400 kV, not say that it should not be used for 220 kV. Nothing wrong in that. So sometimes you have a lower rating. It could be zebra, it could be many other conductors. So when you are choosing that, what is the power which you are trying to transfer? So depending upon that, the conductors are chosen. It could be for higher voltage, a zebra or a bull or a bison. So these are typically used for very high voltage levels. So moose is generally used for 220 kV or a 400 kV twin. We use moose conductors. Yes, as I told, it depends on the power rating of that which you are trying to use. It can be used. And economy is also important when you are going in for the transmission. People also look what is the project cost, including everything. So they are choosing of these conductors depending upon the power which you are trying to transfer, whether it is a single conductor, twin conductor, quadruple. So based on that, people choose. Utilities normally choose this.
Sir, that compensation phenomena, actually, how much is effective, sir? Compensation is given, series compensation, shunt compensation, because generally it is provided in a passive mode. If it is to provide in active mode, so which will be the better, sir? Because when I talk with the HVAC people, they said that we provide directly capacitor banks or inductive banks, reactance banks. So it should be active or passive, sir?
Madam, again, it depends on the voltage level, madam. So what is the rating of that substation? So that is where again this your capacitor bank which is designed, or inductive thing which is being used. Say there suitably these things are designed, madam. What exactly is the MVR capability? Those things again depends on the voltage level, how much you are stepping it down, how much you are using it either for at that instant. So it depends on that. Exactly, I cannot, it will be difficult for me to give the exact values, whether to go in for a capacitive or an inductive coupling. So suitably, they would have planned in the substation to see that whichever is generally beneficial, they normally use that depending upon the rating, madam.
Thank you, sir.
Yeah, madam.
Sir, one more question
Yes, madam.
regarding this surge impedance loading.
Yes,
Now,
madam.
actually, whenever we consider this, it is a lossless line. Most of the calculations is done with the lossless lines.
Correct, madam.
And when we do for the propagation constant or attenuation constant, we have to consider the losses.
No,
So, how we have
definitely,
to
madam.
do
See,
sir?
many of the time, that is what I was telling. For simulation purpose, because of the difficulty, we do choose some parameters which are not exactly the realistic in nature. So we say it is line is lossless line. There is no lossless line in the world where it operates anywhere. There will be some. What exactly is that? We have to have the data for backup. Then we can say how much to consider. That is where I was telling. So these things are available. Like if you have in the substation or a receiving station or the SCADA, the load dispatch centers, is precisely they will be able to tell what is the exact transmission voltages, the generation point, and sometimes depending upon the load, we also see the example in our institute. We have a 66 kV line which is coming. So the incoming is 66. We see at the substation sometimes 68. So the 2 to 3 kV rise because of the Faraday effect, or what you call. So these things are also there. So exactly to find out there is no loss or lossless, it is very difficult for simulation purpose, for ease of simulations. We do choose this, but practically it is not the case. So it is always better. Maybe you can visit the load dispatch centers, either regional load dispatch center in a nearby of these things. You get a solid data. You can discuss with them. There you get the practical actually data that will be really useful when you do the simulation. So assuming that it is completely line is lossless, there is no problems. So those things is good when you see the waveforms which it comes, but practically it may not be that right. There are issues in the transmission. There are losses. To what extent? How much is the loading? How the loading fluctuation, dynamic changes, several things are there in the network which are happening. So it is always better to have. That is where I was telling you earlier. When you have a discussion with this load dispatch centers or the data monitoring where it is being done, you get a better insight of that, where you can input those parameters for your work. It will be a really realistic work, what I feel.
Thank you, sir.
Yeah. Okay, one more question. What is the difference between that we are done? No? Okay, nothing. As far as insulation coordination is concerned, the costly equipment transformer has only get higher value of light. There is Satish Anna has one question. As far as insulation coordination is concerned, the costly equipment transformer has only get higher value of LA. Why? What is the question? Satish, you are there? Yeah, it is like see insulation coordination. Satish, I think why lightning arrestor is being used for protection is basically for the equipment like transformer, which is very, very costly in the substation. So you do have in the beginning lightning arrestors of the substation. Later on for transformer also you have a protection. In case lightning arrestor fails, again for transformer you have a rod gap. So several first, second and third layer protections are available. So transformer is a very costly equipment. You do need to require protection for that. That is where like lightning arrestor acts as a sacrificial thing and it is being used. Is it right answer or what is that? I didn't understand your question. Insulation coordination is to better protect the equipment and see that there is any other equipment which can be used to protect the transformer. Lightning arrestor is used for that. Hey, what is this ABCD parameters? Yeah. Hello.
Ah,
I think there is some problem with the. What is that specific? But for a specific voltage, we have to check the design things. Yeah, these ABCD parameters and transpose, many of these things are depending upon the tower configuration and also the number of circuits in a transmission tower. So several of these things are done taking into the consideration. If it's a single circuit or a double circuit or a 3 or 4 circuit in a transmission line, these parameters will be considered during the design issues. It is not a single circuit where you can simply adopt these parameters. So the designers will be looking into what type of tower, the voltage levels, and how many circuits the tower consists. Then suitably the transposing and other parameters are chosen. So that pi network type. It's still raining. Right. I think it's not coming. I'm able to hear. Maybe reduced. Done. So if there are no questions, I think we can stop.
Yes, sir. If you want, you can close.
Guru, can we stop?
Yes, sir. Yes, sir. You can, sir.
Thank you all for participating. If there is any queries, still you can send us the email. We will try to reply to that.